Hello, hello. Testing. Captain speaking. We live. Welcome to Streaming Frontiers. Welcome to Streaming Frontiers. My name is Captain Jean-Luc. No, it's not Jean-Luc Picard. So it's a uniform from more Christopher Pike era and from Strange New Worlds. But my name is. Where's my lower third? Here we go. My name is Viktor Gamov. I'm a principal developer advocate here with Confluent, and welcome to Streaming Frontiers. Streaming Frontiers is the place and tools and technologies and all this stuff and places as well. Yeah, Cloud is a place. So where no data stream engineer has gone before. This is the regular show on this channel, Confluent Developer, where I will be talking live about certain things that I'm personally interested in. But in this case, you also will be interested in these particular things. All right. I see some people. I see some activities. Let's see. Tony TV. Tony TV is our regular. Welcome back to our Confluent Developer YouTube channel. Let me check my other monitors if the things are working. Yes. So the way how we usually structure this event is we start with introduction, where we're coming from, and what strange new worlds we're gonna visit today. And as always, Tony from Canada. Let's see if we will have someone else from somewhere else. I'm coming to you live from my studio here in beautiful New Jersey. Great weather. You might be noticing one of the things, specifically like this tiny thingy that would be here. Basically, this is it. This is how we're going to be counting our. We're going to be counting a number of subscribers. Right now, we have this number. We need to increase this number. That would be cool if you will subscribe. Which is brings me to let's test if the screen sharing works. So we're gonna go with my screen share. Yes, it is. We have some comments here. Screen sharing works. Confluent Developer, this YouTube channel where you are right now. If you are here somehow and you are not subscribed, please, by all means, subscribe. All right. We do have my colleagues from our community and developer relations team from Atlanta. Live. Nice. I don't know what's a stereo quarters. I don't know what is this. I'm sorry. I'm sorry, Tony. Subscribe to YouTube channel. Now, next thing, quick news, exciting news, super exciting news. Current London is agenda is here, is published. Get excited, sign up. We do have some awesome sessions from awesome speakers. Watch for announcement, but I know that some folks from OpenAI will be there talking about their Kafka infrastructure. There will be a bunch of Confluent folks. I will be there doing not the live stream, but I will be doing my own session. And if you are interested in some community codes, reach out, DM me in LinkedIn or on the back of this channel. If you're interested to join, it's going to be awesome. You just simply cannot miss it. Now, let's talk about the subject. Unless someone, while I'm here, I will be answering some of the requests. So you probably, if you have something to ask or you have some ideas what to talk about in the future the episodes, let me know. And everyone is talking AI these days. So, and we we cannot not talk about AI. And the streaming data is a big aspect of AI. So that's why I mentioned OpenAI. We'll be talking about their Kafka ecosystem, about their Kafka deployments, and how streaming data helps with these like AI use cases. That's exciting, and everyone is like, there's something new happening, like new tools, new ID, new I don't know, use case, how the generative AI is used these days is coming in. So I decide to also a little bit ride the hype train. Hopefully this stream will bring new subscribers. Don't forget to subscribe to our YouTube channel. You will see a number will be increasing if you will be subscribing. This should be in more or less in real time. So let's talk AI, but not just let's generate images. By the way, speaking about generating images, I also decided to use the current trend of the certain things, and I actually implemented a whole presentation in the style of Studio Ghibli. New addition to OpenAI. Just go and check it out. It's a pretty cool presentation. The video is there as well. It's on my speaking.gamov.io website. So yeah, no, we're not gonna do this today. We're not gonna do this AI generated images in this particular stream. We're gonna talk about something different. And the something different that we're gonna talk about is called Model Context Protocol. And it would be very interesting to see development of this technology. And me, on my side, I decide to participate in not only kind of like watching, but actually trying and what it brings for my users, for my developers, and stuff like that. So that's why we're going to be looking into something that's called MCP Confluent. Since again you're on the Confluent developer, we are gonna be exploring some things with Confluent Cloud. But before we jump into this conversation, what's the overall interest in the group? Do we have anyone who is using MCP today, or people who are, doing something with MCP? If you're doing something with MCP, write down your favorite MCP server in the comments here in this stream, while I will be talking things. So I'm not just gonna sit here and wait until you will be typing. Yeah. So it is. Let me bring my The MCP is so hot right now. If you remember this Hansel scene from. Or Hansel entrance to the podium. Yes, MCP is pretty much Hansel right now. Everyone is talking about MCP. We do have people who heard about the MCP, so we're going to talk about this a lot today. Now, so essentially, I should have started even earlier. There is a difference between LLM itself and the clients that we use to iterate or integrate or interact with these LLMs. And usually, the most common way interact with LLMs is through these chatbots. There's different utilities. You know that if you need to interact with OpenAI GPT model, you using application called ChatGPT. Again, I want you to distinguish between actual LLM and chat, the model that the chat application that you're using. So we're using chat application, and essentially that's the client we're interacting. And there's a lot of cool things that we use in this LLM clients that are not part of the API. For example, these Claude desktop or chat GPT application, they will maintain context, maintain some memory about your conversation. So the next interaction with the model would be, you don't need to repeat yourself, or the model can make some smarter decisions. Now, and because it's API, when you will be calling OpenAI or Anthropic, you're calling their API endpoint, and we're using HTTP. HTTP is stateless, and it would be incredibly difficult or even impractical, I would say, for vendors who building these systems to maintain this history of all these events, or history of all these interactions that you have with LLM. So that's why you have some additional services. Like I said, ChatGPT is not GPT model. It's the application that uses API. And this additional information, is basically creates the context with the request. So model itself, like interaction with the model, is stateless. When you ask in the same question, but we will not provide the context from the previous conversation, it will give you different answer, and it will not remember. If you will be asking like, "What's your name?" the system probably will not be able to tell you anything. So that's why context and prompt, the thing that you ask in model, your request, and some additional information around this is important. Now, that's why, since the models are stateless, there's no way for models to go and interact with some external system. It needs to be some additional service. If you want to go, and most of the models, they are pre-trained. So that's why, like, GPT P stands for pre-trained, as far as I understand correctly. Meaning that you don't need to do anything in order to this model to understand you. I will switch back to the screen soon. Now, and they usually, the information that were trained is limited to certain period of time. There's different cutoff. You can Google different models. They have a different cutoff of the information that they were trained on. But how we can deal with the real world information. So that's why there's additional tools that allow you provide the context for the models. And if we want to teach the model, say, Google something, we can write the custom integration. There's plenty of frameworks that allow you to write those interactions with the model, and has the memory, and build this integration. It's possible. You can build this in Java. There's plenty of frameworks, Spring AI, LangChain4j, that's integrates with Quarkus. You can do this. You can do this. You can build this. But here's the problem. Every time when you need to do new integration, you will be essentially writing a new new integration from scratch. And I never realized that, but essentially something came to my mind specifically to this, like, MCP things, and it's kind of like analogy that everyone is knowing. It's called Kafka Connect. So you can write multiple producer and consumer application, and bring the data from the different systems, and so far and so on. But at the end of the day, you writing a lot of repetitive code. So what MCP is doing is essentially provides the ways how to models will invoke some of these standard things in order to get the data. So instead of having the custom integration, there will be the model interaction model between client, in our case, our application that will be talking to model. This application would know how to talk to external tool in case of during the conversation they pick up some of the words that would say, "Oh, apparently I can trigger something." And this something is inside the MCP server. It's called tool. So when the initial configuration is happening, this MCP server will be advertising itself and telling, "Hey, there is a certain tools that you can invoke, and this is description of those tools. This is what you will be able to will be doing this. So that's why you need to have MCP." So again, long story short, you have producer and consumer in your Kafka. This is how you can bring data from anywhere else into your streaming data. Similar things with the custom frameworks and integrations with models. Again, only difference is that Kafka has some memory, Kafka has some persistence. You can, producer and consumer can read the data. Models, they don't. You need to interact with applications or clients. Kafka Connect, similar to MCP Server, allows to have custom integration. So you don't need to worry about the protocol, how the model will be invoking this thing, because it would be standard. And the I lost my train of thought. Yes, the with this MCP server also will, as a developer, you need to implement only small things. Like you don't need to implement the actual transport. So we're gonna be jumping right in MCP. Hopefully, my description of MCP was good enough, or having this the similarities with the Kafka Connect integration. Now, why? Obviously, because we want to make our application that will be using AI capabilities a little bit smarter. A little bit smarter in the sense of we can have some information from recommendation service. So say we're implementing some sort of customer support bot, or some of the things that we will be using as developers for ourselves, like coding assistants for our Kafka applications. Now, if you're writing this, you need to have not only information about data that this model was pre-trained on, but also we need to have information based on the current state of user bank account. Someone is calling, we say use the tool to identify who is calling. We add this information in the context that for a particular session, Captain Pike is calling, and he will be asking about his state of the ship. Like, what's the status, engineering status? So, and you don't have to have like engineering, because you will have a MCP server that will go and touch different aspects of the ship, and will report you and report you back, so you'll get those information. So tools will be integrated, and the data source here, it can be anything. So it can be, where's my library? It can be Kafka. Okay, database. Okay, so what's the data source? We're looking on the page. No. I want to leave library. Where's my library? Library. Can I do search here? No. Can I? No, I cannot search here. But say we can have database. It can be. It can be Postgres. We need to have, it can be Kafka. This is what we're going to be doing today, essentially. Here we go. Kafka would be another data source. And after that, too many Kafkas here. It can be different application. And if you will be Googling, you can find that there's different MCP servers. And this is how we end up here. This is how we end up in our Confluent Cloud. So let's start playing around with this thingy and see how this will work. So specifically, we're going into installation and getting started. So grab this from URL. Before we jump, let me see what's the comments here. Oh, Tony is commenting things here. Great. Boom. Oh yeah, I guess there's some delay, and Tony was commenting things. At the comments. Yeah. this generation of LLMs requests are very similar to the way that use terminal in a sense. Just wanted to mention. Yeah. It's kind of like you still have this text-based games when you will be, making moves and the LLM will respond. Now, let's take a look. I do have, if I have a correct version of Node, so I do have this installed already. Let me switch to my favorite Tmax shell, and I'm going into MCP. And by the way, like there is plenty of MCP servers. If you Google something, MCP servers, you will find something like, bam. There's a formal kind of like a spec that was developed by Anthropic. But say, for example, we do something cloud storage, Google Drive. So we can have a MCP server that will go to your Google Drive and maybe do some search. With some of the MCP some MCP servers you need to install them like open sourced and integrate with different services. Database, for example, Postgres, ClickHouse, StarRocks, Single Store. That's crazy. Yeah, so pretty much every major database has its own integration. So you can, from your application, you will be able to go to those things and get this data. Now, let me close this. Now we're going for the Confluent. I am into my AI MCP, which node? Okay, 22 node version. It is 22. I think we should be good to go. Let's go with this. So I will move away from this, and we're going to be using Node. Now, next thing is that what we need to do. And this is my Visual Studio Code from this repository. I want to make sure that it builds correctly. So I'm using a project building and running. So I can do npm install. And after that, we're going to go with configuration. Npm install. And I think the run the server, just make sure that everything runs. Yeah, Confluent MCP server is running. Okay. Now let's go with configuration. So a couple things are required in this because we're gonna be talking to Confluent Cloud in this. So we need to update some of the configurations. In my case, I do have a cluster where I need to use a little bit of our Kafka key, Flink key, Confluent Cloud API key, Schema Registry API key, and a REST endpoints. Okay, that's what we're gonna be grabbing here. I will allow myself to log into my Confluent Cloud. And I already have some clusters that I used previously. I used for some of the workshops that I did. That's why it's called workshop. And now we need to get some API keys. The fastest way to get this is we going into here and clicking API key. I don't know if this thing still called sandwich, a sandwich panel, but hey, let's call it sandwich. Go to API keys. We're gonna go with API key, my account, click next, Kafka cluster. Let's start with Kafka cluster first. We're gonna do this, and for this cluster, click next, and we'll just do streaming frontiers, Kafka key. Obviously, after this stream, this key will not be available, and there's nothing you will be able to do with this key. So we're gonna do this, getting this key. Now we say complete. next thing is that we're gonna do my account next. Flink region will pick up our same cluster. I think AWS, this is where I run this. Let me see. Going into my environment, go into Flink. That's my here. And let's see if I do have a way how I can get the key. Compute pool environment. I'm wondering how I can get API key from here. CLI instructions, it's CLI. API keys. Okay. So I will add new API key for my account for scope. Okay, so in this case, creating, updating, deleting Flink statements. So we're gonna do AWS and US East 2. We call it Streaming Frontier Flink key. We're getting this Flink key. We're going to do this with Flink secret and click complete. So the reason for this, again, we're doing this because this we want to give some control to this MCP server. Now, organization settings, there's no. I want to go and have one more key. It's going to be my account. It's going to be Cloud Resource Management and Streaming Frontier Confluent Cloud key. I'm creating this one. Copy paste. Confluent. And we're going here, pasting this one. Now, and the last but not least, we need to API key for my account, scheme registry, for environment, and for this one, SF, scheme registry key. I'm gonna go the scheme registry. And that should be it. That should be us. That should be good. We will test it in a moment. Now, in order to configure this, as I mentioned, let me bring this slide a little quick. So we need to now, we have a server. Server is configured. Now we go into this route. So we need to tell this client how to use this. So for this, say I'm going here with my Claude client. We're going to use Claude. Go in the settings, and these there's a Claude can receive information like prompts and attachment from specialized server using model context protocol. So it will give me a link to documentation, but I'm interested in getting this configuration, and this configuration would look something like this. So here we do have nothing. And if I will be Googling or reading documentation from our MCP server, we need to configure a couple things. So we need to configure MCP server with name of Confluent and the comment and location of my NV file and location of my the code of the application. So in this case, I already have prepared this. The reason why I'm using like a full pass here, because I'm running multiple versions of Node, so beware what kind of versions are you using. So in this particular case, I tried to run this. You know, I'm a captain of the ship. Of course, I need to test it out and see if it works. So in this configuration, I save this configuration. We are now need to restart this MCP client. And after, hopefully it will load. Now, as you can see here, it says 24 new MCP tools available now. Like what? How? What? What is happening right now? So, and the reason for that is because the client now, this little fella, knows how to talk to Confluent. Let's try to do something. So there's some tools available. So let's see. Hey, do you see my... Actually, let's try it. Where's my voice recognition system? Where's dictation? Start dictation. Hi, do you see my Kafka topics? Ha, Kaf. Okay, sorry. Let's see if the it will. Because typo, of course. Do you see my Kafka topics? Now, this is the request. So this system, this Claude desktop application never will do anything without permission. So now it wants to use this, and I want to allow this for this chat. So it will be recognize that it saw some topics, and I will just say allow for this chat. And now, all of a sudden, this particular the console now understands a little bit about my my Kafka topics. So let's try to do something else. If I would say, hey, can you record our conversation in Kafka topic? Where is it? Where is it? Can you save our conversation into Kafka topic? All right. Now it uses different ones. It has a create topics from MCP Server. And I say that allow for this chat. Meanwhile, we can open our Confluent extension. As you remember from last time, I hope, previous time we talked about Confluent. And let me log into my Confluent Cloud account as well. So we do log into yes, we do have this one, our topics. And now you see this topic called Claude Conversations. So what we can do is, let's see some messages there. Waiting for messages. Yes, now I said allow for this chat. Now we can, not only, we're using second tool, produce messages. And all of a sudden, we're still having these messages of our conversation. Successful, saved our conversation into Claude conversation. Do you like me at any additional information? Saved conversation. Would like anything else to Kafka topic. So let's explore what we can do here. So let's explore what else we can do with this tool. So as you saw in this conversation, you have a multiple different tools, 24 tools to be exact for current version of this MCP server. For example, let's take a look. Let's try to. So what's the schema situation in my Confluent Cloud? Let's see if it will be able to look up. Okay, so for some reason it didn't call it. Okay, check if there's any SQL statements processing this topic. Yeah, let's try it. So it knows a little bit about the documentation from the tool. And in this case, check if there is any Flink SQL statements processing those topics. Classic situation with Viktor's heavy accent. And SQL, SQL, SQL. It's pronounced SQL, Viktor. Yes, check if there is a Flink SQL statement processing this topic. Now, in this case, at least Flink statements will be used as a tool, allowing this chat. So let's see. Another thing that it's interested in environments. Let's see if it will be able to pick up some Flink statements. So now the next one, get clusters from particular environment. And also some of the additional information, it also saved internally in internal memory. So now we have environment ID, we do have a cluster ID. Claude is quite smart to understanding responses. So it says, oh, there was an error because the array of the parameters were the API that will receive all these Flink statements will receive the array of 2 arguments and it was held 1. And in order to research the second argument, it went and called another API call. It's kind of fun. It's kind of pretty cool. So how we can see all those things are provided here. Now, for Kafka environment and cluster, we have one cluster, Java Flink Workshop, Kafka topics, processing. And as you can see here, it's even picked up the information from Flink. I was never able to directly access Flink statements and might be processing these topics. Let's try one more time. Let's try see if it will be able to do this one more time. Can you see? So I think this is the. Let's take a look on Confluent Cloud. So first of all, let me show you a very quick new feature that is coming to new version of Confluent extension. If we go to settings, go to Confluent, enable Flink related resources. This is super cool. There's gonna be new tab here. Oh, that's nice. Okay, how I can get back now? Where are my resources of the? Let me restart the extension. Okay, restart, install. That would be faster. Try to find a problem. Flink resource is not implemented yet. That's fine, but we will be able to see there's a compute pool that I'm interacting with, and I was wondering if this compute pool, how I can access to this. No, it should be fine. I should be able to access to this information, and I should be able to see a bunch of statements that are running here. Let's try it one more time. There's dictation. Hey, what kind of Flink SQL statements I do have running? So again, we're gonna fix this. Mission should. Okay, want to know. Let's see. Flink statement. Okay, why invalid argument statement? It's cool. Let's see. Create Flink statements. Interesting. Why you want to do this? Okay, let's chat. Let's see what you want to do. So now, this is the where combination like of the model and using this new information that were provided as part of. This is incredible. I think this is awesome. And what happens is it would try to different attempts to get information. What I ask like what kind of SQL statements we have running here in in this whatever we're doing. And what it went, try the different APIs, get the different responses, analyze these responses, updated the model or conversational model between the client, get the data in the real time from my cluster data, and now we can see, I see this is exactly what running inside my Flink. So I do have this job that is monitoring a canceled flights, and this data, this process we extracted here. So for some reasons, it prints out SQL, but it didn't some of the statements. So we do have information about the statements that failed, and it just pick up the information that is there. I'll show you in the Confluent Cloud. We go on here. We do compute pool. We're gonna go here, and there would be statements somewhere. Open SQL workspace, and the bunch of statements are running here already in my workbook that I created for some of the demos. And it was able to get this information. I think it's pretty nice. Now let's see. I have something in my mind. All right, now save this conversation into Kafka topic and also implement Flink SQL job that will count number of words in our conversation. So let's go implement Flink SQL job that counts number of words in our conversation. Let's see. So this is not entirely wipe coding, but I'm just telling, hey, computer, do this thing. And we're producing messages now into all the messages we produced. Now, this is going to be interesting. Create Flink statement. So create table, conversation messages. That would be interesting because I don't think this is going to work because we don't need to use this information. When we're creating statements, these statements will automatically will be used the connector. So let's see. I'm pretty sure this statement gonna fail. Where I can see my statements and go to my cluster workshop. There would be some topics. So Claude conversation topic is here. Messages here. Loading messages right now, hopefully. Yeah, some messages are here. Conversation between user. It's a little bit bigger. Now we're gonna see in here. We're gonna see Flink. We're gonna see Flink statements, and now we see it's failed. So let's ask. Okay. Please check status of previously created statement and make sure it runs smoothly. Now, so I hope it will be able to get information about this statement from, see, okay, all right, so we're getting this information. And reading status, also pretty cool, using multiple different tools, Now, created, to count words, and our conversations failed. This is error. Okay, all right, so. Okay. Now, it analyzes the error, and we'll try to split this in two. So let's see what is happening right now on my Confluent Cloud. Word count query. All right. Interesting. So now, that's what I was saying. So this system doesn't know that we use Flink, but this Flink is much easier to use because it automatically connects to Kafka, so you don't need to provide this Kafka connector information. And hopefully, it will be smart enough and figure out to pick up correct a connector. I'm interested. Okay, so I encountered several issues while trying to set up Flink SQL job in our work conversation. Okay, so now it says only supports Confluent connector. So let me. Nice. It's still trying. It's still trying to do, and hopefully with right decisions that were made based on the data that we require from API, it will just simply remove all this constraint. Hopefully, let's see. Okay, count is our success. Summarize, we successfully created conversation. Let's see if we have any statement that is successfully. No, I don't think so. Let me tell it. So when you're creating statements in the Confluent Cloud, you don't need to specify with Claude. It would be automatically created. Just create statement like create table and insert into table and all these type of things. You need to specify. You don't need to specify. I'm kind of like trying to teach the system with Claude to configure. Okay, it will be automatically created, period. I hope this information would be enough in order for this system try to stop doing stupid things. Let's see. Unsupport. Yep, exactly. So it's incorrect. Let's see if we will be able to create this statement. All right, interesting. Let's see. Insert word counts. What's the error? Okay, now this is something that it can work with. So let's see. Create statement, list Flink statements, getting the statements back. Check the insert statement. Read statement. So it establishes some sort of logic in order to interact with this system. Now it will analyze the errors, invalid argument tool, list Flink statements. Code is too big. Wow, interesting. A little bit of vibe coding in this particular case, just like approving everything. While it's doing its thing, this capability is not only available in okay, let's see. It's continued. It's continued doing its thing. So it found out that the regex extract all is not available or not allowed. It will try to do something. Let's see if it's it will continue to do. Yeah. So what I was trying to say, if you're using tools like, for example, my favorite ID, kind of AI-based ID, that's called Windsurf. So in Windsurf, I can go ahead and also connect to other MCP servers. So in this particular case, I also use GitHub, sequential thinking, or Docker MCP. Say Docker MCP, what it does, it can get list containers like what are containers. I have? Like let's do chat mode. Do I have running? And in this case, I need to run my orb stack just to make sure that the things will be up and running. So what are you doing, little guy? So little guy is doing something. So little guy, please check your network connections. Okay. It was interrupted. We were interrupted. Please continue. What is happening? Boom. Can we stop it? All right. Okay. Maybe it will require like exclusive access to this MCP server from Confluent. Let's see if it will continue. And it was just like, yeah, what containers do I have running? Some containers. Let's see. Boom. So now in this case, like it uses Docker MCP server and got me all the containers in the state. Well, like, but do I have running? Yeah, so it's pretty cool. So in this case, it will allows you to have a little bit more conversation about the things in other places. And like I said, this is it's a standard. So different tools in ecosystem is available. Now, just quick. Okay. Now, the way how this model interacts with our tools is described in this diagram that I stole from the awesome blog post that my colleagues Edward and Sean wrote. So you can check this out in our, I'll just copy this into chat, about certain capabilities. It was very highly inspired by this blog post and the things what I did in this particular configuration. Now, that's what is happening. So LLM thinking determines context, pick up MCP tool, talks to Confluent MCP server. We're getting a response from this server, getting some data. The data now is part of the context, and this is MCP server goes to Confluent Cloud. If there's enough information, for example, successful results, and this is what the model knows, what's going to be enough, or it will ask more information. So that's exactly what this model is doing right now. So successfully accomplished. Let's see if it's actually successfully accomplished. Constant word count. Okay, let's see where this statement is writing data in. Do we have messages in, messages out? All right, great. So save rest of the conversation in conversation topic, and we will test if our Flink job actually works. So in going back to my working job, I'm going with my topics. There should be topic saying conversation word count, I believe. No messages. Let's see if this will continue to produce new messages. The good thing that we have a fantastic tool in Confluent Cloud called data lineage. So I would see. Let's see all the topics. No, I'm actually interested in Claude conversations or conversation messages. Which topic it uses? it uses topic into which topic? Claude conversations. So Claude conversations, and let's see. We do have some data produced there, right? Okay. Okay. We'll try to create new Flink statement. Would you try to create new statement? Conversation word count. Why not? Let's try it. Yeah, why not? Go for it. So we will create a table. Wait. Okay, check the result in the query. Talks, and there's anticipation. I think this is the very, very cool if at the end of this it will work. Okay, so let's see. Will we go in workshop Flink statements? Check word count is running. Select SQL content from conversation word count. Where's the results? Is it streaming back to my Claude? I'm very bad on SQL. I know one person that very good on SQL. It's Robert Moffat. I need to bring him on one of those adventures and missions with Streaming Frontiers. But I know in the past I was saying like it doesn't matter what you know. It matters who you know, so you can ask some of the some of the questions. I think it's stuck somewhere, or maybe waiting for results, and there's no results because we're not producing anything to new topic. But let's see if we can do this. Just if it just work for us in. I'm gonna go to Flink with my open console workspace, and just play one. Can I do this from the very beginning? Initializing, so it will start new Flink job. Take some time. Come on. Okay, nothing. Okay, so in this case, I'm wondering if I can do read statements. Okay, checked. Great news. Both word count jobs are running, and jobs running continuously, and conversation word count table with approximate 1,000 words. So this is the size of our conversation. So it get this in first constant count, constant word count. We're doing conversation word count. I don't see conversation messages, conversation word count. Can I see this topic with say it says like it's empty. Conversation messages, and let's see if we can get information about this topic here as well. Again, empty topic. I don't know why it says it's running and counting words. I will be researching more. Sometimes it can be hallucinations. The job is running, continuously updates the conversation word count table with approximate count. Query is also running, looking at the current contents of the table. One actual result. So so I don't see all the things what this MCP server looks at. So even though we can directly view for the table through API, we can confirm Flink SQL job is working based on the following facts. let me just go ahead and see if I will just go raw in topics and we'll see any data in those topics. And I can do this through UI as well. Yeah, that would be right way to do. Here we're gonna do conversations. We're gonna look into conversations. Conversations are here, so we have these things now. Conversation messages. Let's see if we do have anything here. Schemas was also created. That's what's interesting. Word counts. Let's see if it also will have anything. And from beginning, it should play something. Okay, let's do this one. Okay, save last conversation to conversation topic. And we're gonna save last conversation into topic. We will submit this. So the next time we're gonna see how we can integrate with like IDEs and maybe adding some additional context. For example, here I got to tell it to go and create statements without putting with clause with configuration. So we do have a new messages. That's new conversation came in. I don't see any new messages in conversation messages. There's nothing here. Maybe it uses conversation messages. Okay, submit this. Send few words to conversation messages topic. Send a few words into conversation messages topic. I don't know. Maybe it's uses the wrong topic. It still uses Claude conversation. Anyhow, we're gonna see how this works in the rest of the stuff. But I really wanted to show this integration tool, how to configure this, how it works with existing resources in Confluent Cloud, because I really want to start the conversation. I want to start the conversation about those tools will definitely change the way how we work, how we build our streaming systems, the way how data streaming engineers will be doing things in their professional careers and stuff like that. So I'm asking you, my listeners and my audience, what do you think about this? What do you think about all this AI tooling movement? Are you on the fence? Are you jumping in and also trying different tools? Obviously, it's just like a first iteration. Like everything is like very chaotic. Some of the things are the model still can hallucinate. Whatever happens. But I'm very optimistic. So next time I will try to bring some of the additional integrations. So maybe we can write some code in place, and we will use some information that available in our cloud. This type of information. And let me know what you want to see. Let me know what you would love to learn from this conversation. And with this, I guess we are done for today. We are pretty much covered everything. My name is Viktor Gamov, and as always, please have a wonderful day. And I'll see you in the next adventure.